This is Speed Demon. But how did we get here? We all met as a group for the first time and were given a brief introduction to the buggy's specs. We'd also have an interview for the first time in the course, and were immediately bombarded with two new programs, Fritzing and Arduino IDE. Safe to say the odds were stacked against W13. Very quickly though, some group members were subconsciously taking the lead on certain aspects of the project. In week 4, we learned of the magical H-bridge, a tiny chip that allows us to run our motors in reverse and adjust the motor speed using pulse width modulation. After a lot of rewiring, a fried laptop, and many failures, we finally felt like we were on the right track for the bronze challenge. This program was a lot of fun to use for our GUI. However, the difficult part was figuring out communication between the control computer and the buggy. This was probably the hardest part of the project, but after much trial and error with a client-server model between processing and the Arduino, our interactive GUI and processing could make the buggy start and stop. Finally, it was time for the infamous bronze challenge. 2 laps around the track, plus a test of the ultrasonic sensor. Speed Demon's 2 eyes, which are infrared sensors, detect the line of the track by evaluating how much light that is emitted is reflected back. The buggy's wheel encoders can be converted into the distance traveled by the buggy, as well as its speed. Everything went off without a hitch. After a much-needed week off, it was time to start grinding for the silver challenge, where Speed Demon would have to follow a moving object at a fixed distance, as well as have changing speeds. We once again customized our GUI to account for a speed slider. The difficult part is the PID. This is a type of controller. The buggy is set to be at a fixed distance from the object, and the US sensor reports how far the object actually is. Based on this, the PID adjusts the buggy speed. After 2 or 3 lap sessions, we were fairly happy with the result, and managed to pass the silver challenge after 3 attempts. This meant that we had won a ticket to the gold challenge competition. In week 10, we confronted the Husky Lens camera that had been propped up on the buggy since the very first day. The Husky Lens contains an onboard computer vision system for object detection. The gold challenge consists of a harder course with twists and turns. On top of that, it would be timed for speed and be pitted against the other buggies. The Husky Lens was taught 4 different April tags, which are our road signs. Once the tags were taught, these had to be linked to an action in Arduino, which then was linked to something displaying on the GUI. We had a few issues with the distance at which the camera detected the tags, but this was solved by setting a pixel height at which they need to be. We also worked on a few different GUIs and experimented with a bunch of new features. The morning before gold, everything was looking good. But then, the right motor broke. We had to leave the buggy with the experts and reluctantly packed it up for the day. Before we knew it, it was the day of the challenge, and this day was pure chaos. At some stage, nothing was working. I'll let these clips speak for themselves. We tested Speed Demon on the track for so long that at some stage we were cut off on how long we had before testing. So after 5 hours in the lab, it was time for our first attempt. And fail. That wasn't surprising considering 50% of the time the buggy malfunctioned up until the minute before testing. We reset the GUI and we had one final shot.
We are so in, man. Oh, we're so in. We have a video as well. That's like, oh,
To this day, we still don't know what divine intervention made Speed Demon go straight instead of turning, but we had done it.